Hi, this video explains how to find the center of mass. Now the question is, why should we find the center of mass? It's important in solving problems of collision to know where the mass is acting, and so that we can multiply mass into velocity and find the direction of the path. If you take a simple sphere, we don't have to find the center of mass. It is obviously the center of the sphere. If you take a cube, the center is obviously inside the cube at the center. The same for a rectangular box. But there are certain objects where the mass is not uniformly distributed, and in such cases it is required to do a small calculation to find the center of mass. In this image there is a white looking plate with masses distributed unequally. The blue and yellow are the heavier ones and the pink and cyan are the lighter ones, and let's see what to do here. So take a top view, let's call it y and x axis, and in the top view let's place the masses in a rectangle as you saw in the image. So you have m, 2m, 3m and 4m, just some notional values, and then we have to find out the coordinates, xy coordinates of where the equivalent mass is acting. So take the 2m and multiply it by the distance d, which is a moment about the y-axis, and do the same with the mass 3m multiplied by the moment about the y-axis, and the mass which is at the origin will have no moment. The mass 4m will have no moment because it's sitting right on the y-axis. Similarly, take the moments about the horizontal x-axis. Divide these moments by the total mass and you will get the coordinates. The coordinates here are d by 2 and 7d by 10. This is where the overall equivalent mass of this system is acting. Let's look at an animation. So just to remember what to do, draw an axis, put the plate there, assume there is no mass in the center of the plate, and take a moment about each of the axes. That's all. Just flap the plate. So when you flap the plate, you will understand how to take the moments. Let's do that again. Draw the axis, put the system with the unequal masses, and just flap it. When you do that, you can find the center of mass of any 2D system. So we notice that the coordinates d by 2 and 7d by 10, it's plotted on the same 2D. You can see a star mark, and the star mark is the point through which the mass equivalent is acting, and you can very obviously see that it's closer to the heavier masses, which makes sense. So you can do a quick check of whether the calculation is making sense or not. I hope this presentation was useful to you. Thank you. Bye bye.